So for the first part of this, when you guys were watching the video about the wolves and the reintroduction of those wolves into Yellowstone, one of the things I wanted you to talk about were what were some of the negative and positive things or changes that you heard or picked up from in that video. So let's share our thoughts with that first, and then we'll kind of summarize and recap them. Javen?
One of the positives I had was that the number of species increased.
Okay, good. So as far as a positive, an increase in species. Good. And our negatives on this side here. Go ahead, Ty.
Negatives. Rivers changed. Positive.
As a positive. Okay, good. So the rivers changed.
For a negative, I had to kill a lot of animals.
Okay, so we had species increasing, but we also had some species that were being killed, right? So kind of how I went through this and started breaking everything up, and I'm going to make my pen a little bit more obvious to you guys. If I were to divide my sheet in half, kind of like what you guys have, those two boxes, I just start diagramming it together. It kind of starts with an initial thought, well, that's kind of negative, and it starts the video talking about how they kill off the deer, right? So I kind of put that over here. That's a negative for the deer, at least, right? I guess when we talk about negatives and positives that are happening, some of these things that are negative for that species isn't necessarily negative overall. And so when we walk this line between positive and negative, I'm not saying overall is it bad. I'm saying for that species in particular. Okay, so started off with killing deer, and as a result of that, we kind of cross over here. Their behaviors change. So deer behavior changes. And that goes back to our conversation when we talked about if a species is faced with something. This goes back a couple weeks ago. They have a couple options. They can adapt, they can move to a different area, or they can die. And in this scenario, yes, some of the deer were being killed off by the wolves, but large majority of the deer altered their behavior, so they kind of adapted. They moved to a different area, and as a result of moving to that different area, we saw probably the main reason why we saw a huge shift in the ecological system at Yellowstone. And that major piece was the fact that we had an increase in vegetation. This one factor alone changes so many factors, okay? So that increase in vegetation, all directly as a result of this deer population being driven around, has a trickle outward effect, okay? And when I say vegetation, I mean like grass, trees, all plant life, okay? So one of the first things that they point out is this leads to an increase in birds. Okay, so we're still on that positive side. Increase in birds. We have an increase in that beaver population. That increase in beavers increased aquatic life. Not just fish. I mean, they were even talking about muskrats and things that live in those marine environments. We also had an increase in bears. So as far as species, we had an increase in bears because the bears are feeding on the berries. Now, some people are like, oh, an increase in bears is bad. Not for the bears, it's not. So that's why I'm still keeping this on a positive side. And in fact, they found that the increase in bears, what did they say that the bears then did? Say it louder. Well, they ate the berries, but there was something else that they did that continued to help that deer population.
Didn't they kill, eat their leftovers? The coyotes.
Yes, they do. They kind of cleaned up after them, but they were also eating the young deer. So they would prey on the young deer, which was also helping cut down that deer population. Keep in mind, the biggest issue at that point was that the deer population was becoming too big. And so we had one species that was dominating and throwing off this balance of that whole food web, and it was causing some major issues. Geological, so something that happened to the earth itself, and this is extremely important, is that it decreased soil erosion. The one thing that a farmer knows, or that anyone knows that has anything to do with plants or landscaping or anything as far as us trying to create sustainable areas, is that plant life is one of our most natural resources for reducing soil erosion. So that's why we plant grass in a waterway, because we have water running in that area and you don't want your soil going with it. Same thing with the banks. You guys were outside yesterday looking at the creek, and you guys were all kind of around the bridge area, and there was a lot of big rocks, and what we would call that is like riffraff. So chunks of cement along the banks, we put those there on purpose to help cut down on erosion. The rocks can stay a lot easier than soil can. So some of that stuff is very purposeful in its placement. If we can't do it naturally, like what happened in Yellowstone with regrowing that vegetation and keeping those banks from eroding and eating away, there's a lot of issues that come about. In particular, as a river or a creek becomes really sharp in how it meanders, that picks up speed. Okay, so that causes the water to be a lot less inhabitable than if the waters are calm. Okay, so species can survive a little bit better in calmer waters. Other things that you guys picked up on. We know that, they killed, we can put this over here on the bad side, I guess, on the negative side, not bad side. But they killed coyotes. Bad for the coyotes, right? Not necessarily bad for the ecosystem, but bad for the coyotes. And then some of the direct results or direct positives coming out of the coyotes being killed off is we had that increase in rabbits. We also had an increase just like in small game animals is what we would call that. Yeah, we've spent so much time talking about energy pyramids, food webs, and all of these interactions. And why do we talk about that? Because if you change one thing within that system, you're changing a lot. And it may not seem like a lot. It might seem like you're just doing a little fishing. The fish are coming out of that food web. But the minute you take something out or put something in, because do not forget that often we introduce species. And if species are coming in that are not wanted, what we call that is an invasive species. Okay, and you can put this down at the bottom of your page somewhere, but invasive species are species that are introduced into an ecosystem, not necessarily on purpose, but introduced into an ecosystem, and they have dramatic effects on that ecosystem. So let's just kind of recap for a second. You're going to do this at your table first. You guys have on your notes page, it says food web, food chains, and energy pyramids. The first thing I want you to talk about is what are each one of those? How are they different from each other? What does one have that maybe the other ones don't? Okay, so start with discussing that. As we start to kind of define these things, the first one, the food web, what we're talking about when we discuss a food web is just a diagram that shows all feeding relationships. So Kenny's really touched on that when he says all of it. It's all feeding relationships. You had a bell ringer the other day. What is a feeding relationship? Well, it's what eats what. Okay, so our food web is going to be specifically a diagram, that shows all feeding relationships. And I'm underlining that because that is kind of a key vocab word too. So by feeding relationships, we mean what's eating what. Okay. A food chain, on the other hand, is just going to be direct connections. It's the path that food takes from one organism to another. So it's the direct path. So direct path for food from one organism to another. And I went ahead and put in here a couple diagrams just to side by side look at the difference between those. So if we're looking at the food web on the right hand side, you're seeing all of these different interactions, right? So a spider to a bird. Why is the arrow pointing from the spider to the bird? Well, because we've learned about this. The energy is going from the spider to the bird. The bird eats the spider, and the energy flows in the direction the arrow is pointing. And then on the right-hand side, what we have is just a food chain example. So we could find these species within our food web on the left-hand side. So we have an owl, mouse, grasshopper, grass, and sun. So as you can see, it's the flow of energy showing the sun is giving the grass energy, the grass is giving the grasshopper energy, the grasshopper is giving the mouse energy, and then the mouse is giving the owl energy. And that chain is just one component or one piece of that particular ecosystem. Your food web is really designed to try and show all of those organisms, the whole community of organisms within that ecosystem. Okay? Our energy pyramid, on the other hand, if we're going to start defining this, we do have to include that. An energy pyramid is really going to delineate out those trophic levels. So what we mean by that is it's going to break out the trophic levels that exist within an ecosystem. Trophic levels would be a feeding level. Remember, those are the different levels like what Kenny's referencing: producer, primary consumer, secondary, tertiary. So it breaks out the various trophic levels. I'm going to underline that and just give you a couple examples. So what we mean is producers, consumers, okay, decomposers, and it is so important. I think Chase is the one that touched on this. It's going to show us that transfer of energy from one level to the next. Okay, transfer of energy. Let's keep in mind 10% rule. That 10% rule is telling us that one trophic level can only pass on 10% to the next, which means 90% of the energy that's in that one level is being utilized either by the organisms within that level or being transferred, not lost, but transferred to the environment around it. So let's take a closer look just at the example here. And there's some things I don't like on this diagram, but it works for the purposes of what we're talking about today. Your producers at the bottom, and then you have your primary consumers, which are your herbivores, your secondary carnivores, and that would also include omnivores. That's one of the things I don't like about this diagram. Secondary carnivores, and then your tertiary. Now, if we're talking about, primary, secondary, tertiary, and quaternary. So these are all consumers. I know that this isn't labeled perfectly for what we're talking about, but these are all consumers. This is the producer. And then keep in mind, decomposers, where would they be getting their energy from? All of it. So your decomposers would be consuming energy off of everything.